Hello everyone. This is the video for mainly Chapter 7, Lesson 8. I don't have a video filmed for Chapter 7, Lesson 7, but you guys were all with me when we did that. So I'm just going to review a few methods of working out multiplying binomials. So um, there's two methods. One is the box method, and one is the FOIL method. So I'm going to do both. We'll do the box method first. So one way we could look at it is basically by separating out each binomial into individual terms, going horizontally and vertically, and then creating boxes where we're going to basically multiply each part of what we see and put the answer in the box. So 3x times x would be 3x squared. Negative 4 times x would be negative 4x. And then 3x times 2 would be 6x. And negative 4 times 2 would be negative 8. So when we bring this all out, what we have here is 3x squared. And in the box method, a lot of times diagonally, we can see that there are like terms. So negative 4x and 6x would become positive 2x. We bring them together, and then minus 8 or negative 8 goes down. And so that is your final answer here. That is the simplified version of the product of these binomials. Now, what if I'm using the FOIL method? So the FOIL method is really just multiplying the first term, the outer terms, the inner terms, and the last terms. So the first terms would be these two. That would be n times 4n, which would be 4n squared. The outer terms would be these two. So that would be n times negative 7, and that would be negative 7n. The inner terms are these two. So that's negative 6 times 4n. And so that's negative 24n. And then the last terms. So negative 6 and negative 7 are positive 42. These terms in the middle, similar to the box method, they are usually like terms. So those can be combined. Negative 7n and negative 24n make negative 31n. So it'd be negative 31n plus 42. And that is the final answer. Now, with the FOIL method, I do not expect you to have to write out 1, 2, 3, 4 sets of problems, basically. This is something you should be able to just like keep track of in your head and start to be able to do. So if I were to do that here, I'd be looking at 2p squared times 2p. That would actually be 4p to the third power, because p squared times p would be p to the third power, 2 times 2 would be 4. Then I do the inner terms. So these two, or sorry, the outer terms. So the outer terms, negative 5 times 2 makes this negative 10p squared. Okay. Then the inner terms. So 2p times 3 would be positive 6p. And then my last terms, which would be negative 15. And in this case, when I work this all out, I actually cannot combine anything. There are no like terms because all my degrees of each term are completely different. And so that's our final answer there. So moving on to lesson 8, multiplying special cases. So the square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the second term. Okay, so what is this even talking about? Let's put this in practice. So your example, when you have a square of a binomial, so this is a binomial, it's just being squared, which really means you have this being multiplied by itself twice. Well, instead of expanding everything out like we had to do with our box method or our FOIL method, which you could do and get the right answer, what you'll start to notice that it's the square of the first term. So first term right there. It's the square of the first term plus twice the product of the two terms. So basically, these are my two terms here, A and B. It's twice the product of the two terms, 2 times A times B, plus the square of the second term, plus the square of the second term. Okay, so if you even want to have this little section, this little part memorized, a plus b squared equals a squared plus 2ab plus b squared, that might help you with when you actually see numbers put in place of these terms. So let's do the box method just to double check to see, what all is happening here. So it's a plus b times a plus b. They're all positive, so I'm not going to put any symbols or signs around them. So this would be a squared, right? Then I have a times b. So a times b. And then a times b down here. And then I have b times b, which is b squared. So if I bring this together, this is 1ab and 1ab, which combined together makes 2ab. So this becomes a squared plus 2ab plus b squared. All right, let's talk about if there's subtraction. So if there's subtraction, again, we have squared of the first term plus twice the product of the two terms. So when there's a subtraction, it's going to be a negative or a subtraction sign here, minus 2ab. Because if we're multiplying everything, a times negative b times 2, if I rearrange this, it's negative 2ab, right? That negative would go out in front, and then I would go my numbers first, and then go in alphabetical order. Then the plus the square of the second term. Okay, so what does this look like as a boxed method? Let's just double check to make sure it's working and it's correct and it lines up with what we're saying in the box method. So I've got A here, negative B here, A here, negative B here. A squared, A times negative B is negative AB. A times negative B is negative AB. Negative B times negative B becomes a positive, and it's positive B squared. So when I bring this over, this combines negative 1AB plus negative 1, or plus negative 1AB is negative 2AB. So A squared minus 2AB plus B squared. So let's look at this with numbers. It's going to be x squared plus 2 times the sum of the two terms, or product of the two terms. So 8 times x is 8x. 8x times 2 is 16x. Last term is 8 squared. That would be 64. So plus 64. Let's check with our box method. If as I'm doing this and I'm working this out, it's just still having a hard time, you're still having a hard time working this out without the box method, just do the box method. There's really nothing wrong with it. This would be 8x. This would be 8x. And then 8 times 8 would be 64. 8x plus 8x is 16x. That matches with our answer up here. Okay, over here, x squared. Because it's a subtraction sign, it's going to be a minus 10x, right? 5x times 2 is 10x, and then plus 25, because it's 5 squared. Let's check. Hopefully you can pause and work this out yourself, or you can fast forward because you maybe feel like these are easy and you can do them. And then just check your answers. Negative 5 times negative 5 is positive 25. Remember, a negative times a negative is positive. Negative 5x plus negative 5x is negative 10x plus 25. So what's a simpler form of each product? Let's kind of take a look here. So really, it's the first term squared, right? N squared, plus your negative 7n times 2, and your last term squared. So this would be n squared minus 14n plus 49. Negative 7 squared is 49. What if I have a number and a term over here? So it would be first term squared plus the sum of the two. So not the sum of the two, the product of the two. So 9 times 2 is 18, and then it would be, so it'd be 2 times 9 times 2x, all right? And then the last term squared, bring this down. This would be 4x squared. Why is it 4x squared? Because 2x times 2x will make it 4x squared. Then 9 times 2 is 18. 18 times 2 is 36. This would be 36x plus 81. Let's check it with the box method. When in doubt, do FOIL or do the box method. Both will give you the right answer. So on your test, I would like to be able to see that you can do each method, but I probably won't specify for all the problems. 18x, 18x, 81. Add these two together, that's 36x. Okay. The product of a sum and difference of the same two terms is the difference of their squares. So let's talk about that. Look what that looks like is the difference of their squares. So if you are multiplying basically the product of the sum and the difference. So you're multiplying them as binomials. However, one's an addition, everything's the same. The terms are the same, but one's a positive, one's a negative, or one's an addition, one's a subtraction. What ends up happening is it's the difference, meaning subtraction. So the difference of their squares, meaning a squared and b squared. And that's the final answer is 2 squared minus, or a squared minus b squared equals, or sorry, a plus b times a minus b equals a squared minus b squared. What ends up happening is the middle terms that we see that normally add up as like terms and you add them together, middle terms cancel out. And that is why in our final answer, we're left with basically the difference of the squares of those terms. Let's take a look at it as a binomial. So a positive b, a negative b. This will be a squared. This will be a b. This will be a times negative b, which is negative ab. And then b times negative b, negative b squared. Positive 1ab plus negative 1ab cancels out. They both have the same coefficient. It's 1 in the front, but one's positive, one's negative. They cancel. We're left with a squared minus b squared. Let's look at it with numbers. Our answer should be x squared minus 9 because 3 times 3 is 9. Let's test it out. X and positive 3, x and negative 3. This will be x squared. This will be 3x. This will be negative 3 times x. And this will be negative 9. Positive 3x and negative 3x cancel out. I'm left with x squared minus 9. Last bit, problem 4. So working out these problems, hopefully it shouldn't be too crazy. It's going to be the squares of the two terms. So x squared minus 81. Here, I'm going to square these. That would be 36. Square these, and that's going to be m to the 4th power. So it's 36 minus m to the 4th power. If you want to, show your work and just double check, you could do this. And just double check, right? 6 squared is 36, m squared and squared. Remember, we can multiply 2 times 2 is 4, m to the 4th power here. Okay, this would be 9 c to the 2nd power minus 36, right? Negative 4, or 4 times 4, 4 squared is 36. And that's it. If you want to double check, you could look at this, right? Squared, and then 4 squared. This will distribute in. And then your 3 squared is 9. C squared is C squared. 4 squared is 36. Wait, it's not 36. It is 16. That's what I meant to write. 16. So maybe checking your work is a good idea, right? Because I'm looking at this, I'm like, 4 squared is not 36. It is 16. I must have looked at the 36 from up here. Anyway, that's all you have. So there's a lot of kind of loopholes and tricks that help you do these types of squares of binomials. And it's just a matter of remembering them. So the more you practice, the more you're gonna kind of feel like it's second nature. All right, that's all I have for you today.